Previously, we learned the ratios that each trigonometric function represents. For example, considering this triangle, sine of theta equals the opposite side of angle theta over the hypotenuse of that triangle. And the same goes for cosine of theta equals the adjacent side of the triangle over the hypotenuse side, and tangent of theta equals the opposite side from the angle under consideration over the adjacent side of the triangle. Similarly, we learned that cosecant of theta is the reciprocal of sine of theta, in that the ratio just gets flipped. Like here we see that cosecant of theta equals the hypotenuse of the triangle over the opposite side, which is just the sine of theta flipped. And the same for secant of theta equaling the hypotenuse over the adjacent side. That's just cosine of theta flipped over. And cotangent of theta equals the adjacent side over the opposite side. That is just tangent theta flipped over. We call that a reciprocal. Now that we've learned how to identify those ratios for each of the trigonometric functions, let's see how to actually evaluate these functions with a given angle to get an answer, to get the ratio. So for this video, I'm going to use two calculators. I'm going to use a scientific calculator that's very similar to the ones that we have, the TI-36X Pro, but I'm also going to use another one which is more similar to the TI-30XA, which some of you might have, or if you don't have that exact model, you have something very similar to it. So I want to cover both calculators to see how we evaluate these trigonometric functions. So first, let's consider this first row right here. First, let's consider this area right here, just the normal trigonometric functions. So sine of 60, how we would plug that into our calculator, and 60 here, again, I want to show is representing theta. This is representing the angle of the triangle. The angle of the triangle is 60 degrees, and we want to evaluate it to determine what the ratio is between the opposite side and the hypotenuse side. So to do that on a calculator similar to the TI-36X Pro, we enter sine, we enter our angle of 60, and we press the equal sign. And here we see it's 0.866025404, and that number probably keeps going. For our example problems here, it says round to 2 decimal places. So I'm going to go ahead and write 0.8, whoops. I'm going to write 0.87 to round it off. If I remember that correctly, yep, 0.87. Now let's clear the calculator, and you usually have a clear button or something that says AC, and let's try it on this different calculator over here. For this calculator, we would have to enter the 60 first and then click on sine, and that yields us the same answer. However, this calculator goes out to many more places. Now we see that it's 0.866, and if I press equals here, it actually saves it to a history or a memory, which your TI-36X Pro has a memory that is stored so that you can reference earlier calculations that you had made. We can see it here, and it's the same answer. There's no difference, just a little bit different method. Let's do some more examples. So the cosine of 48. The cosine of 48 on our calculator, similar to the TI-36X Pro, we would hit cosine, hit 48, and then press equals to get 0.669130606, and it keeps going on. To round this to 2 decimal places, it would be 0.67. So I'm going to come over here and write that in, 0.67. And on the other calculator, let me clear this history here. We would press 48 first, and then click on cosine. That's 0.669, and it keeps going on. That rounds up to 0.67. And you see I pressed equals and my value is saved so that I can reference it later. Let's try tangent 50.555. So I would say tangent 50.555 equals. I get 1.2154, dot, 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 dot. I'm going to round that to 1.22. If I got that right, yep. 5 will round to 1 up to 2. And I'll do that on the other calculator as well. So here I would put in the angle first, 50.555, and then click on the tangent button. I get the same answer.